Hi everyone, this is Dr. Sandeep, working as Associate Professor in Mechanical Engineering Department, Institute of Aeronautical Engineering, Hyderabad. So, we are discussing about the material science engineering. So, in the previous sessions, we have discussed about the introduction to material science, material engineering. And the second session, we have discussed about the physical properties and the mechanical properties of the materials. Now, in this today's session, we are going to discuss about the structure of crystalline solids. So, first of all, we need to know what is atomic structure. So, every material will have its own atomic structure. Okay, so an important reason to have an understanding of interatomic bonding in solids is that in some instance, the type of bond allows us to explain the material properties. So, what is the importance of the atomic structure means? So, depending upon the interatomic bonding in solids, we can describe the mechanical properties. So, once you want to know the mechanical properties, we need to know the atomic bonding in the solids. So, this helps us to find out the mechanical properties of the materials. So, for example, if we consider the carbon, so this carbon exists in both the graphite and diamond. This is not both the graphite and diamond. But what is happening here? The graphite is relatively very soft and has a greasy nature. The graphite has very soft and greasy nature, but diamond is the hardest known materials. Okay, though the carbon is available in both the graphite as well as the diamond, what is happening? The graphite is relatively very soft and is also having a greasy type of feel when you touch the material. But when you go with the diamond, it is a very, very hard known material. Now, what is happening? Why we are discussing like this? So, in addition to this, if you want to know the properties of both the graphite as well as the diamond, why we are taking this example only means since the carbon is a common element in this, since the carbon is common element in both the diamond as well as the graphite, we are trying to find out the mechanical properties involved, and we are trying to compare the mechanical properties between these two elements. Now, if you compare the electrical properties of the diamond and the graphite, both are dissimilar. Though the carbon is present in both the elements, the electrical properties, that means the conductance, electrical conductance is dissimilar between these two. Why means? Because of the atomic structure. As we discussed, atomic structure varies, interatomic bonding varies for each and every material. So, this interatomic bonding try to describe the mechanical properties. That's why we have taken the two carbide as well as diamond elements and we are trying to compare what are the properties. Now, if you consider the electrical property between these two, they are dissimilar. Why means? Diamond is a poor conductor of electricity, but graphite is considerably reasonable. When you compare with the diamond, graphite is having a reasonably good conductance of electricity. Like that, you can differentiate the properties by knowing the interatomic bonding between the atoms or the molecules. Now, what is happening? Because of these disparities in the properties and directly attribute to the type of atomic bonding, interatomic bonding, which is found in graphite, does not exist in diamond. So, like that, you need to compare the atomic structures of different elements in order to find out the properties of the material. Now, each atom consists of very small nucleus. So, if you see in this figure, so this is an atom. So, in this atom, you have a very small nucleus. So, this is a small nucleus what you have, and this nucleus is composed of neutrons, electrons and protons. Okay, if you see this, so this is an atom which is composed of very small nucleus And this nucleus is composed of electrons, neutrons and protons. Clear? And what is happening here? Each atom consists of very small nucleus which is composed of protons and electrons and which is encircled by moving electrons. Okay, and this is encircled by the moving electrons. So these are the moving electrons. See the picture clearly. You can identify how the electrons are there, neutrons and protons. So in the nucleus we have proton and neutrons, and the electrons are being encircled over the nucleus. Now both the electrons and protons are electrically charged. Both the electrons and protons are electrically charged. Now you can see the electrons are having negative charge. Electrons are having negative charge. Protons are having positive charge, and neutrons represents for neutral charge. There is no charge for this. Okay, so you need to find out which is having a positive. Electron is having a negative, protons are having a positive, and neutrons are having neutral. So in the name itself you can easily identify. Positive for P, so protons, so you are having a positive charge. Electrons, negative charge. Neutral, neutron, there is no charge. So like this you need to identify. So what is happening here? In the atomic structure, each atom has a small nuclei. This nuclei is again having, what is having? Neutrons and protons, and the electrons are being encircled on the moving of the atom. Now both the electrons and protons are electrically charged, and the magnitude of the electrons and protons are 1.602 into 10 power minus 19 coulombs. The magnitude of the electrons and protons are 1.602 into 10 power minus 19 coulombs, which is negative. We have mentioned here, which is a negative. Electrons and protons are having a negative sign, and electrons are positive and neutrons are electrically neutral. So this you need to find. So the atom is having a nucleus, then this nucleus is having neutrons and protons, and electrons are being encircled, moving over it. And here what is happening? The neutrons having no charge, protons are having positive charge, electrons are having a negative charge. And if you want to find out the magnitude, both the electrons and protons are having the same magnitude, which is equal to 1.602 into 10 power minus 19 coulombs. And if you compare the masses of these subatoms, okay, this is very, very small, is it not? Since the protons and electrons are very, very small, the masses also, if you calculate, it will be very, very small. So the protons and neutrons have approximately the same masses. The neutrons as well as the protons are having approximately same masses, which is approximately equal to 1.67 into 10 power minus 27. So very, very small, very infinitesimally very small value of mass for the protons and neutrons. This is equal to 1.67 into 10 power minus 27 kg. That means very, very small value, and which is significantly larger than that of electrons. So electrons are having 9.11 into 10 power minus 31 kg. Okay. Now this is about the masses of that protons, electrons and neutrons. Now coming to the other thing, each chemical element is characterized by the number of protons in the nucleus. Okay, each chemical element, will have its own atomic number. How can you tell that atomic number? By knowing the number of protons. So each chemical element is characterized by its number of protons. By calculating the number of protons in the nucleus, you can easily find out the atomic number of that chemical element. So this is the atomic number, which is represented by Z. So what is that atomic number? Atomic number is nothing but the number of protons in the nucleus. That is called the atomic number. Now, for electrically neutral or complete atom, complete atom, the atomic number also equals to the number of electrons. What is happening here? Electrically neutral or complete atom, the atomic number also equals to the number of electrons. So now this number of electrons, how it is varying means, it is varying from the range of 1 to 92. So for 1 starts with the hydrogen and 92 ends with the uranium. So this is a hierarchy of the atomic number in the table. Now the atomic mass. So atomic mass is specified by capital A. Okay, capital A. So atomic mass of a specific atom can be expressed as the sum of the masses of protons and neutrons. So how can you find out the atomic mass of any element? You have to add the sum of the masses of protons and neutrons within the nucleus. Then you can calculate what is the atomic mass. Okay, it is the summation of masses of protons and neutrons within the nucleus. Now, although the number of protons is the same for all the atoms of a given element, the number of neutrons may vary. So, since the protons almost for every element, the number of protons are almost same for all the atoms, but here neutrons are varying. So that you have to find out. Now, thus atoms of some elements which are having 2 or more different atomic masses are called as isotopes. So what are isotopes? What are isotopes means atoms of some elements which are having 2 or more different atomic masses. Then that type of element are called isotopes. So first you need to know what is atomic mass. Atomic mass is the summation of the masses of protons and neutrons. And in some cases, most of the cases, the number of protons will not vary for most of the elements, but the number of neutrons will vary. And in some elements, which have 2 or more different atomic masses, those are called as isotopes. Next, coming to isobar. What is isobar? Isobar differs in atomic number or number of protons, but have the same mass number. So isobar differs in atomic number but have the same mass number. That is isobar. But coming to isotope, what is happening there? It will have different atomic masses, 2 or more atomic masses. That is called isotopes. Isobars are having the same mass number. So that is the difference between isotope and isobar. Now, the atomic weight of the element corresponds to the weighted average of atomic masses of the atoms naturally occur in isotopes. So how to find out the atomic mass unit? AMU, atomic mass unit, can be computed with the help of atomic weight. So we have the equation as A equal to Z plus N. So what is A here? A terms to atomic mass, Z represents for atomic number, and N for neutrons. So this is how you can calculate what is the atomic mass of any element. So atomic mass of any element is equal to sum of the atomic number and neutrons. So A equal to Z plus N. So this is how you can calculate the atomic mass number. So that is about atomic mass. Now coming to atomic bonding. So the bonding again describes the physical properties. How the bond between the two elements will describe the property of the material. That's why the atomic bonding is very, very important. So in order to find out the physical or mechanical properties. So an understanding of many of the physical properties of material is enhanced by the knowledge of interatomic forces that bind the atoms together. So if you want to understand the physical properties or mechanical properties, you need to know how the atomic bonding is there between the two atoms. If they are closely packed together, that means they are a good bonding between them. It is having a good mechanical property. If the bond is very, very weak, that means the body is very weak. You are having very less strength, less hardness values. So the atomic bonding, if you know the knowledge, if you know the idea of the atomic bonding of the material, then you can easily enhance or improve the mechanical properties or the interatomic forces between the atoms. Now, the principles of atomic bonding are the best illustrated by considering how two isolated atoms interact as they brought close together from an inspired separation. Okay, so if there are two bonds like this, if they are separated by some distance, that means there is no bond between them. There is no interaction between them. So, without interaction, there is no proper bonding between them. That means there is a reduction in the properties of the material. There is a reduction in the mechanical properties. But when you compare the other atoms which are closely bound together like this, that means it is having a good properties, mechanical properties. So that is how. Now, since you know the bonding between the elements, between the atoms, since you know the bonding, with this knowledge you can improve, you can enhance also by using some techniques, hot working process or cold working process. You can use those and you can improve the properties of the material. That's why the atomic bonding is very, very important to increase, or basically if you want to know the what is the bonding between them, to understand the physical properties. Now, at large distances, interactions are negligible since the two atoms are very, very large distance. So what is happening here? There is no interaction. That's why the interaction is negligible, since there is a huge distance between the atoms. So because the atoms are too far and which are very apart to each other, there is no influence on each other. Since there is a lot of difference between these two atoms, as well as the interaction is negligible, the influence between these two atoms is very, very less. So there is no influence between them. But in the same case, if they are closer to each other at small separations, what is happening? There is some chances of interatomic force exerts between these two, and it tries to bond between them. Okay, that's why the bonding can be calculated by the spacing between the atoms. If they are very near to each other, there is a chance of force of attraction between them and they try to create a bond. But once the distance is very, very high, then there is no chance, there is no influence of bonding between them. So that is one of the criteria. Now these forces are of two types. What are those two types here? Attractive force and repulsive force. Attractive, when the distance is very, very less between the elements, it is attractive. They're attracting to each other and they're trying to get a bonding between them. But once they are away from each other, if the distance is very, very high, this R is very high between these two elements, there is a repulsive force. There is no interaction between them. Okay, so that's why we have two forces in this atomic bonding. One is attractive force, that is called Fa. Fa is nothing but attractive force. And another one is Fr, that is repulsive force. And the magnitude of each depends upon the separator or interatomic distance. So how can you find out the magnitude of these two? Means depending upon this R value. If the R is very less, then it is an attractive force. If R is very, very high, what is happening? You are getting a repulsive. So in this case, what is the thing we can identify here? Since R is having a larger magnitude, then it is called as a repulsive force, Fr. In this case, since R is very, very small, so it is an attractive force, Fa. So that is how you need to find out what are the forces involved in this atomic bonding, whether it is a repulsive force or attractive force. So by plotting the graph between the Fa and Fr with respect to R, then you can easily identify what is happening with respect to the distance. Okay, whether it is if you increase the distance, what is happening? There is an increase in the repulsive force. If you are trying to decrease the R, the attractive force is being increased. So that is the logic between Fa, Fr and R. So we will see the plots between these three to identify what type of forces we are getting with respect to the distance. Now, the origin of an attractive force Fa depends on the particular type of bonding that exists between the two atoms, is it not? So, how to start? Where is the origin of that attractive force? How can we find out? We can find out the attractive force origin by depending on the particular type of bonding. So what type of bonding existing between the two atoms? If you know the type of bonding existing between the two atoms, then you can easily find out the origin of that force Fa, attractive force. Even the repulsive force arises from the interaction between the negatively charged electrode clouds for the two atoms, which are important only at the small values of R. Okay, small values of R at the outer electron shell of the two atoms. Now you can see this figure. You can easily identify what is happening between the repulsive force, attractive force with the R, with the distance of R what we are maintaining. Now this is the origin. Okay, this is the origin what we have, and this is the negative direction, positive direction, and towards negative we have repulsive force. This is the repulsive force, and towards positive we have attraction. Since both are attracting to each other, that's why it is a positive. So we are taking this above the origin. That's why it is a positive. Repulsive, there is a lot of difference between the two atoms. That's why it is getting repulsive force. There is a huge difference. That's why it is negative. So that's why we are taken below the origin. So repulsive force is negative, attractive force is positive, and this is the origin line. Whatever the line we are seeing, this is called the origin line. Right. Now, slowly you can observe repulsive force arises from the interaction between the negatively charged electron clouds. What is happening? Repulsive force. Now see, in this figure, because there is a huge gap, there is the gap. You can find out the R. Since you are getting a huge gap, there is a lot of disturbance. There is no bonding, proper bonding between the elements. If the distance is coming nearer, what is happening? There is a bonding between. You can observe the bonding is being starting at this point. Why? Because there is a very less distance between the atoms. So you are getting a close bond and is almost reaching to the origin line. So the interatomic separation between the two atoms is very less. So at that point, you are reaching the two atoms closer together, and it is trying to reaching the origin, where you will get the combined bonding of the element. And since the distance is higher, you are getting a repulsive force. So this is the repulsive force. So if you maintain the distance larger, then that leads to the repulsive force. If you are trying to reduce the distance between the atoms, you are getting the attractive force. So that is the representation of this graph about the forces. So repulsive force arises from the interaction between the negatively charged electrode for the two atoms, and are important only at the smaller values of R. Smaller values of R only we are trying to get the interatomic distance is very less, the bonding between the elements. If you are having a higher range of R value, the interatomic radiation, there is no attractive force. We can find only the repulsive force. Now, to find out the net force between the two atoms, if you want to find out the net force between the two atoms, what we need to do? We need to find out the sum of the both of the attractive as well as the repulsive forces. So, Fn represents for the net force. Net means total. So what are the two forces available in this? We have the repulsive force as well as the attractive force. So summation of attractive force and repulsive force gives the net force between the two atoms. So in order to find out the net force between the two atoms, you need to use this formula. Fn is equal to Fa plus Fr. Fn represents for the net force, Fa represents for the attractive force, and Fr represents for the repulsive force. And this is also a function of the interatomic separation, is it not? So interatomic separation depends upon the R value. R is nothing but the distance between the two atoms. So this net force is also a function of interatomic separation. So this is what we have seen in the plot, in the previous plot. There we need to balance the attractive force as well as the repulsive force. In order to balance the attractive force and the repulsive force, what we have to do? We have to equate them to 0. So Fa plus Fr is equal to 0. So this is the net force, and this is called as the state of equilibrium. State of equilibrium. So you are trying to balancing both. That's why it's called as the state of equilibrium. Now the center of the two atoms will remain separated by the equilibrium spacing or not. Whatever the center of the between the two atoms that are there, so they are remain separately by the help of this equilibrium equation. The spacing of that are not. Okay, so we are balancing the equation by making with respect to the R value, so that Fa plus Fr is equal to 0, that is attractive force, and repulsive force is equal to 0. That means there is an existence of equilibrium between these two forces. Now the other plot, which is attractive, repulsive and net potential energies. So till now we have seen about the force of attraction between the two atoms, whether it is a attractive or repulsive forces. Now if you want to see the energies also in terms of potential energy, the net potential energy as a function of interatomic separation between the two atoms, you have to use this equation En is equal to Ea plus Er. So what is En? Net energy. Net energy in terms of energy, okay, net energy is equal to the attractive energy plus repulsive energy here. So both the energies in the previous cases, it is in terms of forces between the two atoms, and in this case now net potential energy, which is a function of the two atoms which are being separated by a distance r, that can be calculated by En is equal to Ea plus Er. So the net curve is the sum of the attractive and repulsive forces. So what are the curve we are getting? That net curve can be calculated with the summation of or sum of the attractive as well as the repulsive curves, and the minimum is the net energy curve corresponding to the equilibrium spacing. So always the energy curve, how it is varying, it depends upon the distance, the interatomic distance, how that R value is varying, whether it is closely or it is having higher value. So depending upon the R value only, the interatomic spacing can be described, and from that interatomic distance we can find out what is the net energy, that is net potential energy, or net force with respect to repulsive or attractive force, as well as the energy, that is the potential energy with respect to attractive energy as well as repulsive energy. Furthermore, the bonding energy of these two atoms corresponds to the energy that is minimum at the point. I'll show the figure now. So it represents the energy that would be required to separate these two atoms to an infinity separation. So this is the plot of attractive, repulsive and net potential energies as a function of interatomic separation for two atoms. So now we'll draw the plots for attractive, repulsive and net potential energies as a function of interatomic separation for two atoms. Okay, we are trying to draw the plot for attractive, repulsive as well as net potential energies as a function of interatomic separation of the two atoms. So again we'll take this as origin, and this is the negative. Below the origin you have a negative, and above the origin it is positive. Now the attractive force, if you observe the difference between the graphs of the forces and the energy force, here we are getting attraction in the negative zone and repulsive in the positive zone. But if you compare that force of attraction between the two atoms, here the repulsive is negative in case of forces, and attraction is positive in case of forces. Now this is exactly opposite. What are the energy, potential energy graph you are drawing? This is exactly opposite now. What is happening here? Attraction force is towards negative and repulsive force is towards the positive. Okay, now if you plot the graph of attractive, repulsive as well as the net potential energy between these two interatomic separations, how we are getting, we can see here. This now the repulsive energy, what are the green line you are seeing, this repulsive energy is slowly coming, it is falling to the origin. Why? Because the interatomic distance, that separation, the R value is very less in this case. So slowly it is falling and coming to the origin, closer to the origin. But if you see the attractive energy, the EA value, the attractive energy, what is happening, since you have higher values of E naught, so this is coming from positive and it is going to negative direction, and then since the R value is slowly coming down, that's why it is coming near to the origin. But there is no that much interatomic bonding between them. It's very less when you compare with the forces. Instead, in case of force, there is a very good bonding between the two elements. But in this case, what is happening, because the interatomic distance is very high here, the bonding between the elements is not meeting to the equilibrium condition. It is not matching to the origin. That's why we are having a space here. So the repulsive energy is trying to come to closer to the origin at this point. But when you see the attractive force, it is coming from positive zone, directly it is going to negative zone and reaching the maximum value. This is the maximum value. Okay, the attractive energy maximum value, and from that point it is reaching to the origin to form a bond. So this is how you need to draw the plots of attractive, repulsive as well as the net potential energies with respect to the interatomic separation of the two atoms. So finally, if you want to find out the net energy, En, what is the formula to find out the En? So En is nothing but sum of the repulsive energy plus attractive energy. So this is the formula we have to find out the net energy. So this energy we are finding by adding both the energies. So this is how you need to calculate. Now if you compare both the figures of the repulsive force as well as the potential energy graphs, now it is easy for us to identify and compare between these two graphs what is happening. Now the same thing we are drawing here. You have the origin, positive and negative. Now you compare easily. So in the forces, the attraction force is moving towards positive. This is towards positive. Now when you see here in the potential energy, what is happening? The attraction force is towards negative because of the interatomic distance. Similarly, when you see the repulsive force in terms of force, this is towards negative. But in terms of potential energy, it is moving towards positive. So these two main difference you need to identify while drawing the potential and force curves with respect to attractive and repulsive forces. So these two you need to identify. First one is force. So in case of force, repulsive is moving towards the negative and attraction is moving towards positive. When coming to the potential energy, the attraction is moving towards negative and repulsive is moving to the positive. So these two you need to identify. So what is the next step? Next step is the interatomic distance. So how the bonding is reaching to the equilibrium condition, to the origin. if you see these two figures, see here, there is a good bonding at this point. Both the atoms are being close together and coming nearer to origin. Okay, but in this case, see here, in the potential energy, what is happening? It is coming from positive, reaching to the negative zone. So here you are having the maximum value at the negative zone. But in this case, at the origin only you are having the maximum value. So that is the difference between again. Okay, so here you are having the maximum value in the negative zone. From that negative zone, the attractive energy is moving towards origin. But in this case, what is happening? The attractive force you are getting above the origin, that is a positive value you are getting, the attractive force, and slowly meeting together and reaching to the equilibrium condition. So that is the main difference between these two. And if you want to find out the net force between the two atoms, so what is the formula here? You are using net force. So Fn is equal to summation of attractive force plus repulsive force. So this is the formula what we are using in this case. Now coming to the potential energy, if you want to find out the net potential energy between the two atoms which are separated by the interatomic distance, then you need to use this formula. Net energy En is equal to summation of repulsive energy plus attractive energy. So these are the two formulas which are used to find out the energies as well as forces in the interatomic bonding between the two atoms which are being separated by some distance r. So this r is playing a key role in this case. Okay, the interatomic distance is playing a key role in order to find out how the attractive force is varying and how the repulsive force is varying in terms of forces, as well as the energy, how the potential energy of the attractive as well as repulsive forces are being varied, and how we are calculating the energies with respect to the origin. So see here, you can observe the repulsive force is the positive. Above the origin you are getting a positive value, and here you can see exactly opposite, you are getting a negative value. So all these things you need to identify. So how you are getting the repulsive force and as well as repulsive energy. So these two you need to calculate. An attractive force, you can observe attractive force is below the origin, you are getting the negative value in terms of energy, but in case of forces you are getting the positive value. So all these things you need to find out, and how that attractive force is coming down. Attractive force is coming from positive, reaching the origin, and again going to negative value and having the maximum value at the negative, and from there it is going to the origin. That is in terms of energy. But in case of forces, what is happening? The attractive force is coming positively and reaching directly to the origin. So that is the interatomic bonding between the solids. And if you know this interatomic bonding between the solids, it is easy for us to describe the physical properties, and also it improves us to enhance the quality or enhance the mechanical properties by knowing all this atomic bonding. So if you want to go to the books of the atomic bonding, you can study these books. Introduction to Physical Metallurgy by Sidney Havner, and Essential of Material Science and Engineering. This is a good book, Donald Axland. And Material Science and Metallurgy by Kodgiri. And next, Material Science and Engineering by William Castler. So these four books, you can get the information of the interatomic bonding, how to draw the graphs, how to find out the net forces, how to find out the net energy, potential energy between the two atoms, and how to identify the interatomic bonding. And depending upon the interatomic bonding, how can you justify the material to the required application, and how can you enhance the material properties. All these things can be learned with this atomic bonding topic. Okay, thank you for listening.
Like, share and subscribe. Hit the bell icon for more updates.